Alright, this is a quick example of how to do one of the problems on our atomic size in the mole lab. If you're measuring silicon dioxide, which is the marble or glass, let's say we measured this. So this is in our data table at the top of the page. This is what we know. Then when we do a factor label problem, we always start with what we know. So we're going to put this in the top left box. And then the first actual math problem that you're supposed to do is solve for moles. But before that, in your data table, it says what's the molar mass of SiO2. So silicon weighs 2809. Oxygen weighs 16, and there's 2 copies. So if I plug that into my calculator, I get a molar mass of 60.09 grams per mole. Make sure to include this unit on your work when you're doing your work and in your data table. So since I'm trying to get rid of grams and go to moles, molehill tells me 1 mole is the same as the molar mass in grams. So I'm going from grams to moles, grams down here, moles on the top. It's 1 mole, 60.09. So again, this is a measured value. The molar mass is only ever going to be stacked with 1 mole. It causes grams to cross off. You're left with moles of SiO2. So if I take my 6.210 times my 60.09, I get a pretty small, if I take my 6.210 divided by my 60.09, I get a pretty small number, 0.10334. So in your data table, you have 4 sig figs coming from the 6.210. The 0 counts because it's on the right-hand side of a non-zero, and I see a visibly drawn decimal point. That's moles of SiO2. So this is the first column in your data table, how many moles you have. The next column asks you how many moles of each element. So looking at this formula, I have a container basically that holds elements. So for every one of those containers, I have 1 Si, which means that for every 1 mole of that container, I have 1 mole of Si. For every 1 mole of SiO2, I have 2 moles of O. So when we do our next problems, we're going to take what we know about our substance and we're going to convert it into moles of each element. So my 0.1033 moles of SiO2, notice I'm keeping my unit here because that's going to make it easier for me to understand what's going on. And the same as 1 mole of SiO2 will be equal to 1 mole of Si. I can use this fraction because these are equal to each other. 1 mole of the Si is equal to 1 mole of SiO2. Moles of SiO2 cross off, which means that this is the same number. So that's one of your answers for the moles of each element. You're going to again start with the amount of SiO2 you have. And you're going to convert this into moles of oxygen. So for every 1 mole of SiO2, I need my moles of SiO2 to cross off, I have 2 moles of O. So again, I have this container. For every 1 container, I have 1 of these. For every 1 container, I have 2 of these. It's coming from the subscripts. So I need to take my 0.1033 1033 times 2, that gives me 0.2066. I still have 4 sig figs. So that's my second answer in the moles of each element. I need to then convert these numbers into how many atoms of each element. So 0.1 0.033 moles of silicon need to get converted to atoms of silicon. Remember that 1 mole is equal to 6.02 times 10 to the 23rd particles. So for every 1 mole of silicon, there are 6.02 times 10 to the 23rd atoms of silicon. So I'll take my 0.1033 times 6.02 second key EE to the 23rd. That gives me a pretty big number, 6.2186. So I have 4 sig figs, 1, 2, 3, 4, 8 followed by 6 turns, so 9, 6.219 times 10, and then I have to read the power off my calculator to the 22nd. That's atoms of silicon. And then I need to likewise take my amount of oxygen here, 0.2066 moles of O, and I need to convert that to atoms of O. So for every 1 mole of O, I get 6.02 times 10 to the 23rd atoms of O. So 0.2066 times 6.02 to the 23rd equals 1.2437. You get 4 sig figs, 3 followed by 7 turns to 4, 1.244 times 10 to the 23rd atoms of O. You have 2 other problems on your table. One of them is copper. So whatever your copper is, for every 1 mole of copper, I have 1 mole of copper. For your calcium carbonate, for every 1 mole of calcium carbonate, I have 1 mole of calcium, 1 mole of carbon, and 3 moles of oxygen. Hope that helps.